Hello, and welcome to this edition of Mr. Chappell's Chemistry Screencasts. Today, you're going to learn about drawing Lewis dot diagrams. What you'll learn about today, oddly enough, is how to draw Lewis dot diagrams. Now, there are a couple of things you're going to need. You're going to need a periodic table, and you're going to need the Lewis dot diagram procedure. Now, if you've forgotten what that procedure is, you can do Lewis dot diagrams in 5 steps, and here they are. Now, I won't bore you by reading through each of these, but if you don't have this list with you, what you might want to do is pause this recording and go ahead and write this stuff down. And with that, let's go ahead and try an example. Okay, here we are with our first problem. And our first step in drawing a Lewis dot diagram is to add up all the valence electrons. So let's start out by making a little table. We've got 1 nitrogen and 3 hydrogens. And the number of valence electrons for nitrogen is 5 electrons. And for hydrogen, it's 1 electron. And we should have 8 electrons total when we're done drawing this molecule. So for our second step, we're going to draw a trial structure, and this is with single bonds connecting all the atoms. For step 3, this is our counting step. We started in step 1 with 8 electrons, and if you count, we have 2, 4, 6 electrons. In our trial structure, that means we're missing 2 electrons. So for our final step, what we need to do is put those 2 electrons there so that everyone has 8. And hydrogen's happy with 2, so we'll leave him alone. But you'll notice the nitrogen only has 6, so he needs 2 more. And it just so happens I have 2 more to give. And so that's our acceptable Lewis dot diagram for this molecule. Okay, let's try the second one. It's got a few more electrons. And we start with step 1, and let's go ahead and tally up all the electrons we have. We've got 1 carbon, we have 3 hydrogens, and we've got 1 fluorine. And carbon has a total of 4 electrons, and hydrogen has a total of 1 electron, and fluorine has a total of 7 electrons. So if we add all those up, what we should get is 14 electrons. Now, for a trial structure, we said in class that carbon likes to connect up 4 times, so that's more than either hydrogen or fluorine, which like to connect up once. So probably carbon would be the proper choice for what's in the center of things. And it's not going to matter which bond we choose to put with fluorine; they're all equal. In step 3, our counting step, we need to take the difference between 14 electrons, which we got in step 1, and the 8 electrons that we have from step 2, 2, 4, 6, 8. And that leaves us with a total of 6 electrons that we have yet to put down. So in step 4, what we're going to do is go ahead and put them there. And everyone's happy except for the fluorine. The carbon in the middle has a total of 8, and this fluorine only has 2, so he needs 6 more to get 8 total. 2, 4, 6, and everyone's happy, and this is your final answer. Okay, for our next one, we're going to do bromine. And bromine has oddly enough, only 2 bromines in it. And each of the bromines has 7 electrons. which is going to give us a total of 14 electrons. For step 2, no prizes for figuring out what the trial structure is. There's not a lot to go on, just 2 bromines. For step 3, well, we started with 14 electrons, and we only have 2 electrons there. So that gives us a total of 12 electrons that are left over. So for step 4, we need to put those electrons there, so that everyone who needs 8 has 8, and both of the bromines need 8. They each need 6, in fact, to make 8, and it turns out we've got 12 to give. So 2, 4, 6, 8, 10, and 12. And we have our total number of electrons there correctly, and everyone's happy. Okay, well, you notice we did not have to invoke step number 5 for any of the examples that we did. We're not going to be so lucky with these guys. Now, again, the 5th step is a last resort. You only do the 5th step when you're unable to give everyone an octet from step number 4. And let's go ahead and do this first one. This is formaldehyde for those of you who are interested. And for those of you who aren't interested, it's still formaldehyde. We've got 1 carbon, we've got 2 hydrogens, and we've got 1 oxygen. So that's going to be 1 times 4 electrons for the carbon, 2 times 1 electron for the hydrogen, and 1 times 6 electrons for the oxygen. So that's going to give us a total of 12 electrons. For the trial structure, it's going to be just as well to put carbon in the middle, since he likes to connect up 4 times. Now, we only have him connecting up 3, but that's the best we can do. For step 3, well, we started with 12 electrons, and we only have 2, 4, 6 there in our trial structure, so that means we're missing 6 electrons. So for step 4, what we're going to do is put them there. And the hydrogens are happy just the way they are. Now, a lot of people ask, well, should I put them on the carbon or the oxygen? It turns out if you just follow all the rules, it's not going to really matter for you. So I'm just going to put them around the oxygens, 2, 4, and then finally 6. And you'll notice that everyone has 8, well, except for the carbon. The carbon only has 6. We can't put any more electrons because we've got a total of 12 there. We're not allowed any more than 12. So now we're going to invoke step 5. So let me draw the structure down again and show you how this is done. And for step number 5, we're going to play Robin Hood. And that is, we're going to take away from the rich and we're going to give to the poor. So I'm going to take away 2 electrons from the oxygen. And now I'm going to put 2 back as a shared pair between the carbon and the oxygen. And now everyone has 8. We have 12 electrons total. And this is your final answer. Okay, this is our last problem. And for step 1, we've got 2 carbons and we've got 2 hydrogens. So it's going to be 2 times 4 electrons and 2 times 1 electron, which is going to give us a total of 10 electrons. Okay, for step 2, I need to draw a trial structure. And this is what I get. Now, unfortunately, this does have a trial structure that does not pan out very well. That's where you have 2 hydrogens on 1 of the carbons. You notice I'm trying to make it as symmetrical and keep each of the carbons as equal as I can. That's usually how you can avoid having a trial structure that doesn't work. Okay, for step 3, I started with 10 electrons, and I have 6 there. and that means I'm missing a total of 4 electrons. So for step number 4, I'm going to go ahead and put those electrons there. And I'm going to try to keep things symmetrical, although that turns out not to totally matter. And you notice that each of the carbons has 6 electrons, and I have no way of giving them an octet without exceeding the 10 electrons that I'm allowed. So for step number 5, let me go ahead and reproduce the structure. Okay, again, I'm going to take from the rich and give to the poor. So I'm going to take away 2 electrons, and I'm going to put 2 back as a shared pair. Okay, well, you'll notice the carbon on the right now has 8, but the carbon on the left still has 6. Well, darn it, if it worked once before, maybe it'll work again. So I'm going to play Robin Hood once again. I took 2 away, and then I put 2 back, and there you go. I've got a total of 10 electrons. Everyone has 8, and this is our final answer, and that concludes our lesson. But wait, there's still more. It's joke time once again. Hey, did you know that marathon runners with bad footwear suffer the agony of defeat?